Yeah, the dump variables, then okay, but you need to specify the test bench, and in the test bench also the very most important thing is the instance creation. Okay, the linkage between the test bench and the design. So that is most important. Another thing is like the test bench, the inputs are modeled as registers so that we can save the values. Then to the finish before finishing the installation, you make sure that enough delay is there. Okay, otherwise you won't get the output for the last one, right? So let's go ahead for how should I proceed? Fine. So let me can now what we have seen, like what is this? An inbuilt keyword, right? Oh, which color is this? Okay, this is the keyword, right? We have used the already present keyword, but say for example, we need to define our own keyword, or we need to define our own function. Say for example, I'm having something. Okay, take any example. I'm having a circuit, I don't know what's inside that, but I'm expecting its output, some output. Say for example, there are some 2 inputs, or let's say 4 inputs, whatever. Let's consider 2 input and 1 output. Let it be x, x1, x0, let it be 1, or let it be e, b, and a, b, and 1. Assume that this is an odd detector or an even detector. Let's say assume as an even detector. You can take one more. So we know the table for this, right? I mean, if A, B, and C are there, 0, 0, 0, and all combinations of them. You want the output y to be 1 only if the even number equivalent decimal should be even. Only in that case the y should be 1. If you want that, should be 1 here, 0, 1, 0, 1, 0, and so on. Okay? But this is not built inside. I mean, what you will have to do, you'll have to, like, how do we design this circuit? Like first of all, we form a truth table. After that, we form this. We will form a K-map out of it, right? What is that? You see, it's an XOR kind of pattern, right? It's A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, with starting from 0, 1, okay, so 0, 1, 0, 1, 0, 1, 1. Last second even detector, na? Oh sorry, okay, 1. Are we 0, 1, 2, 3, 1 is it? समझ तो गए ना? even detector करना है 0, 0, 1, 0, 1, 0, 0, 1, 1. Now 0, 0, 1, 0. 0, 0, 1, 0, and 1, 0, 1, 0. 1, 0, 1. So what is the, ये ऐसा ग्रुप कर सकते हैं और ये ऐसा, that's it, right? So what is the expression for this? BC or what is this? A C bar AC bar. So this is the expression for y. So how can we do this? Simply by having some AND gates, OR gates, and normally with the help of gate level design we can do that. Suppose we don't want to do it, and let's say we want to reuse it again and again, and this is what is the most frequently used design. Assume that. So can we define everything in that? Like as we are having the keyword like AND, okay, in the Verilog, we already know that the output will be one, only both of them will be one. So can we make the Verilog understand that we want such kind of module, okay, which would output only even numbers are there. That means we need to define our own what is called as a keyword or a primitive, you can say. So how can we do that? There is a syntax for that. So in the Verilog you can write primitive. Primitive is nothing but a keyword. In primitive, what primitive you need to define? So let's say for AND we are writing AND. So you can define your name, the primitive name. So let's say it is it's an odd detector or an even detector. Let it be even underscore det. It's an even detector. How many inputs and outputs are there? Now, the thing to note is, the primitive can only have one output, unlike a module. Module may have multiple outputs. Again, a gate may have, see, this AND, NAND, OR, NOR, XOR and XNOR and NOT. यहाँ पे एक ही आउटपुट अवेलेबल है, मतलब okay, output is only one, but this may have multiple outputs. Okay, we may take out multiple outputs from this. Okay, but just remember that most of these keywords are having only one output. So primitive का syntax ऐसा होना चाहिए कि पहला जो रहेगा variable, okay, that should always be output. Okay, unlike the module. In the module we simply specify the variables to be used, but while defining the primitive, we must make sure that the first entry is always the output. So let it be y, a and b, right? Semicolon. Now you can define that. How to define? What are the inputs here? Inputs a and b. Output is y. Now we need to make it understand, okay, this is what we want the output, okay. So we need to form what is called as a lookup table, using which the Verilog would understand, okay, I need to throw the output one only if the even numbers are detected. So you need to form a table. So let it be table. In the table, okay, now you make the entries. How many are the inputs? A and B, right? Now again, you should specify the order of the inputs properly. I mean, if A is specified, you must write the corresponding entry for the A. If B is specified next, you must write the corresponding entry next. Okay, otherwise there will be a problem. So table, enter 0, 0, I mean all the combinations, and the output is specified with a column. So okay, I am writing it here. I am going for 2-bit. Okay, time. So 2 0 0 0 1 1 0 1 1. Output will be 1 for even. Even कौन सा है ये ना? Otherwise it will be 0. Is that okay? And table. Once you define this, okay, you can use this in the module as a keyword. So you start writing your code, okay. On the right hand, again, the thing to note is, see, we don't need to write the test bench and the Verilog code separately. You can write the whole thing in single code, in a single Verilog code on the right hand, on the left. Okay. So you can start writing this. Okay. Design a primitive, or what is called as a user defined primitive. UDP. Primitive is nothing but a keyword. Okay, or a function we are defining. Huh? No, this is not a test bench. See, registers are required only during the test bench. Okay, this is like a we are just specifying the directions of the variables. The registers, I am defining these inputs as reg,
only in the test bench, just because we are modifying those inputs, right? Here we are simply mentioning the lookup table. Okay, I'm not saying that okay, after 10 seconds it should change or so on. There is no change which is happening here. That's why we don't need to define them as a resistors. Alright, so once you define this primitive, you can use them. You can use it like a normal keyword, right? I mean, how do we use it? Then for that purpose, we'll have to define a module, right? Define a module. How to define a module? Module name. Let it be, event detector ka use. Okay. So I am writing it as event detector. Okay, any name. Okay, I am using this, so I am just using event detector ka use. Now, here it's not necessary to specify the order, like output first and input next. No, it's not necessary. So I may define as A, B, C, and so on. So parentheses. Semicolon is important. Then tell me input. Which are the inputs? A, B. Output. Now we can, we must make sure that this is defined already. Once this is defined, we may use this. How? We may directly use this keyword or a primitive name. What is that? Event detector. Alright? And if output is there, then A, B is there, Y, A and B. That's it. End module. What is this? We have defined a module or the main code for Verilog. So it consists of both the primitive, the module code. Now we need to test this, right? So we need to go for a test bench. Do that. Any problem till now? Don't look here. Write your own code. Go to VDAplayground.com. You should be able to write your own code now.
Alright, so the thing to mention is user defined primitives. Okay, so design okay, write a Verilog code for even or odd detector, whatever you wish. Okay, event detector, maybe 3-bit. Okay, 3-bit event detector. So example, define a user defined primitive UDP to detect equivalent even numbers for 3-bit binary representation. Alright, go for it. Log on to trying start your program with primitive. Write here primitive name, event date, semicolon. Now you need to specify the output input y, a, b, inputs are a comma b, output y, well, there's something important to note here. This A and B, I am defining them as individual bits, right? I mean, A indicates an individual bit, B indicates an individual bit. But you know that binary or equivalent decimal term is like combination of A and B, right? So alternatively, we may define the variables as vectors also. Okay, so now I am merging two things, right? I am defining the primitive, I am defining the variables not separately but combined fashion, right? So let it be a single input x, which is like a vector, okay, having 2 bits equivalent, right? So for example, I may write it something like this. So input may be only x, but x is a 2-bit vector. I can define it like 1:0. 1 being the MSB, 0 being the LSB. Always remember leftmost bit is MSB and the rightmost is LSB x. So this is what the syntax is. Okay. Now I am doing two things here. I am defining the primitive. I am also defining the inputs as vectors. ठीक है, मतलब स्लो करके जाते हैं. ए इनपुट ही ले लो, ए बी, ठीक है, कोई दिक्कत नहीं. उसके बाद ये सक्सेसफुल हो जाए तो वेक्टर कर लेना, ठीक है बच्चे, ठीक है. ए बी, उसके बाद you need to specify the table. टेबल लिखो. टेबल में क्या लिखेंगे? In all the combinations of A and B, 0 0. Output is, now wait, I am defining a 2-bit. Yes. Yeah, after that semicolon 0 1. Oh wait, here it should be colon 1 0 should be 1 and 1 1 is 0. End table and end primitive. Alright, is this clear? Anyone who didn't get this? Any problem till now? Alright. Now, okay, once this primitive is defined, we need to use it in the module. Define module, give another name, event date. Yeah, using is I am simply writing use. Now I may define the input output. Okay, so this is, you can, okay, let me first finish this. A, B, Y, semicolon, input is like A, comma B, output is Y. Okay. Then, yeah, what should I write here? I need to use this, right? Primitive. So the name of the primitive is event date. I'll be using that. Simply write that. Should have the same syntax. Y comma A comma B, semicolon, end module. That's it. Can write your own test bench now. Yeah, it's simple. Write your own test bench. So test bench should redirect to what? This one. Okay. So see here. So you may consider this one. Okay. Oh, I'm not able to capture this in video. So now it should be. So what I'm saying is this. This is the main function. You can consider that as a main function. This is the module which or a primitive which we have defined. You may consider that as a user-defined function. And the test bench which you will be writing should redirect to the main function, right? So you write your test bench, or you may continue writing your test bench in the same code on the right hand side. Okay, I'll do that now. I'll write as module. So event date, test bench for TB, then okay, so fine. After that syntax बोलो क्या लिखूं यहाँ पे? reg a comma b, ठीक है? output y बोलो. Okay, you can generate instance. So always write it as in last step, just because we are simply calling it. So after that, so I'm generating an instance, this one, right? So write the instance name. Don't forget to write the instance name. Okay, don't forget to write the instance name, otherwise वो काम ही नहीं करेगा. देखो ट्राई करके. After that, बोलो. Initial sets the initial value. Oh wait, why it is not happening? Initial begin. बोलो. Dump file. So I'm writing the same name. Use dot. See, if you don't write dot vcd, then also it will pop an error saying that vcd file is not found. ट्राई करके देखो, इसके साथ खेलो. ओके, ये निकाल के देखो, वो निकाल के देखो, कुछ भी डाल के देखो, आपको फिर कुछ भी एरर्स मिलेंगे. डंप वैर्स 1 Now main thing, बोलो A, I'm varying these A values, B values. उसके बाद okay. Zero. Try to write by your own. B1. Now before that you should give a delay, otherwise you may not be able to notice. It's so short. By default the delay is 1 picosecond, so it's like very short. Zero, 1 1. After that bolo end module, that's it. Is that okay? So I didn't write anything on the left. Have you noticed that I didn't write anything? Okay, so ये double slash जो है वो normal comment होता है, okay, single line comment. If you need to go for a double line comment or multi line comment, you can say normal C like, okay, slash star, and enclose it with star slash and so on. Oh, it's not working here. It's not working here. Yeah, this like this. Okay, so double slash indicates one line comment, star and slash star indicates multi line comments. Slash star and slash slash. Yeah, one more important thing is see, whenever we are designing any circuit, I said that whenever we are using gate, that is equivalent to creating an instance, okay, in the language of Verilog. Whenever we are connecting the wires, okay, that is also called as generating nets. Okay, you must know these jargons. Okay, what I am saying is so using gates or predefined keywords is also called as a primitive, is called as a bolo instance. Predefined keyword or primitive, it may be a module, okay, which you have defined. Then connecting interconnections, or wires are also called as nets. तो सिमुलेशन के दौरान जब आप प्रोफेशनल सॉफ्टवेयर यूज करोगे तब ये ऐसे शब्द आएंगे. ओके, creating netlist means simply creating the internal connections, that's it. So nets means internal wires or connections. Alright, so let's run this, see if it pops any error. Okay, we need to select a valid simulator. So select iCaras Verilog, run IPView. After run this. Yes, oh yeah, good, that was a good observation. But ठीक है, मेरे को 3 के लिए तो आउटपुट आएगा, और दैट इज मतलब वही इंपॉर्टेंट है कि 2 के बाद 1 आ रहा है या नहीं. ठीक है, मैं लिख देता हूँ. उसके बाद इंपॉर्टेंट थिंग वाज टू मेक आफ्टर लाइक 10 nanoseconds आई एम मेकिंग इट फिनिश. इफ यू डोंट डू दिस यू वोंट सी द आउटपुट फॉर लास्ट केस, है ना. रन करो. Right, so I think this is fine. See, as expected, AB 00 01 1011 output should be 1 for 10, right? A1, that is equivalently 2. Okay, so output is 1. See here, the output is 1. Okay, so Y is 1 only if A is 1 and B is 0. That means 2, equivalently 2. For other cases it is 0. That means it is acting as a 2-bit even detector. Okay, this is fine. So here we have seen multiple things. Okay, क्या क्या देखा हमने? पहले तो हमने देखा कि यूजर डिफाइंड प्रिमिटिव कैसे डिफाइन करते हैं. ठीक है, यूजर डिफाइंड प्रिमिटिव, हाउ डू वी डिफाइन दिस? using the keyword, okay, let me go up, using the keyword primitive, okay, after that primitive name or the keyword name, user defined name. Always make sure you should specify the output first. Why? Followed by inputs. It can only have one output. You specify which are the outputs, which are the inputs, okay. After that, lookup table. Lookup table should be included in table and end table. The syntax is, it should follow the same flow of variables as you have defined for the primitives, okay. I mean, so for the declaration of inputs, A and B are there, so this inherently means A and this inherently means B. First entry is A and next is B. Colon indicates the output, the corresponding output for 0, 0. That means if A is 0, B is 0, the corresponding output is 0 and so on. And terminate the line with a semicolon. Don't forget to do that. After that, end primitive. Fine. Then we need to make use of this keyword. Okay, now the Verilog know that we have defined a separate user defined keyword or a primitive which we can define or which we can use in any module. So we are defining a module. We are making use of now you can write your own name. You can, no problem. Then the set of variables which we shall be using, A, B, Y. Which are the inputs, which are the outputs. There is no, it's not compulsory to specify the order of output and input in the module definition, but definitely in the primitive definition. Then we are using it, we can directly use this event det in bracket or in parenthesis y comma a comma b. That means we are calling this primitive or function. Following that, we are defining a test bench to test if everything is working fine. Now this should redirect to the main module. Okay, so there is no need to have these variables, okay, because it doesn't interact. It simply interacts with the main module. It doesn't interact with itself, with its internal environment. You define inputs as reg, outputs as y. Okay, then we are creating an instance. Now this is very important. Instance name is very important. So instance name is must. After that, initial, begin, dump file. Now this everything you know. Alright, next thing we have noted is we can write all the code in single file. That's what we do in iCarus offline. In offline, we are creating a single text file or a Verilog file where we are copying all this code and then we are running it. Alternative is, for separate thing you can cut, paste there. So this is only the test bench, and if you run, it will run smoothly, no problem. Yeah, fine. Alright, so the thing which we missed, okay, let me recall again. The inputs, okay, A and B, now I am defining it as a single variable or a single vector. Now it's a 2-bit, okay. Can we define this as a 2-bit? See here, यहाँ पे ध्यान दो. AB, let's say I don't want separate inputs to be there. I want only one output, one input. Let it be X, but it's a 2-bit vector. So how to define a vector? First, define what is the range of that. It's from 1 to 0. That indicates that it is from 0 to 1. I mean 1 to 0. I mean 1 is the MSB, 0 is the LSB, and so on. What if I write it 3 here? Sorry, 3 here. It is a 4-bit vector, including 0, and so on. Which vector? Now you should specify the name, comma, not comma, X. Okay. So what this indicates? A 4-bit input vector X. Okay. So we just want 2 bits, so from 0 to 1. That's it. Output is a vector or a scalar. See, output is only a scalar, right? So it should give me 1 or 0. So we don't need to specify this as a vector. All right. Now once you do this, okay. Now see, yeah. So A, B, input X. Now there are only 2 inputs and outputs. Yeah. Now here also you need to define the inputs as vector 1 to 0, which is X, and output is Y. All right. Now the input which we are defining in the test bench, which we are giving in the test bench, now that should again be addressed as a vector. Okay. How to do that? So again here reg, which is again a vector. That means that there are no, it's not a single flip flop. There are multiple flip flops, or an array of flip flops which are available. So same way, 1 to 0 x. After that, now here again the instance is x comma y. Sorry, is that okay? After that, now here we need to change these things. Okay, now this is not a and b. Now there is x of 1 and x of 0. Okay, those are x of 0 and x of 1. So the syntax is x, simple, in bracket x of 1 and x of 0. That's it. Can simply copy this. So 0 0 0 1 1 0 and 1 1. Hope this should work fine. Let me see. Okay, so there is an error at 3. Oh, here, yeah, A and B, right? So it should be X here. So even detect. Again same error, 1 to 0. Okay. Alright, so this should be y comma x. Not here. That's why it's fine. To 0. I think the vector is not operating properly in the primitive. It should work. I don't know why it's not working. Okay, fine. Let's restrict ourselves to not this, but we'll come to that. We'll come to the vector point later. Alright, so this should run. Now, fine. Yeah, can you find the error? Where is it? Defining the test events twice. right? So okay, let's look at the text, the vector pattern later. It is possible. So let's avoid that right now. First of all, let's go for different. Okay, except primitives, what we'll do is we'll use this vector concept. Okay, not in the primitives, but other than primitive. Let's see how. So this is what the code was there. Okay, let's take another example. So assume you need to define, let's say, a 2:4 decoder. What is a decoder? We have seen that. What is a decoder? If I am saying it's a 2:4 decoder, what does it mean? Let the inputs are A and B, and output is like this Y0, Y1, Y3, Y2, Y1, Y0. Can you tell me what would be the output? Yeah. डिकोडर दोनों डिकोडर नहीं बताया, ठीक है, कुछ नहीं है उसमें. देखो, जब 0 0 रहता है तो पहला बिट 1 होगा, 0 1 होगा तो दूसरा बिट 1 होगा. इसको डिकोडर बोलते हैं, ठीक है. नाउ इट्स सिंपली अ बाइनरी टू डेसिमल डिकोडर, यू कैन सी इट. बट बहुत सारे टाइप के डिकोडर हमने देखे, BCD टू ग्रे, बाइनरी टू ग्रे एंड सो ऑन. ये बहुत ही पिद्दी वाला डिकोडर है जो क्या करेगा, देखो यहाँ पे 0 0, so only one bit will be 1, which is that this one, others will be 0. This is a decoder. Okay, then 0 0 0 1 1 0 1 1. All right, so only this will be 1 and others will be 0 and so on. Demux बताया था. So mux is like you need a selection line. In decoder, we are, see, there is a difference between an encoder and encoder and multiplexer, decoder and demultiplexer. So see here, I'll just quickly tell you. Mux तो पता है. Mux क्या करता है? Depending on selection line, it will simply connect the inputs to the output. Okay, which input has to be connected to the output? It depends on the selection line. Demux does the reverse operation, right? So mux and demux will require a selection line. So always remember, whenever you see selection lines, multiple inputs, one single output, and always remember that they are having only single output or single input. Okay, mux maybe 1 is to 2 to the power n, or demux will be 2 to the power n is to 1, only one output. Regarding the decoders or encoders and decoders, there is there is a selection line is present. There is no requirement of selection line here, right? I mean, I just want for 0 0 it should be 1 here and so on. So this is a kind of a decoding of binary to the equivalent bit. I mean, this is like, now what this indicates? If the corresponding bit is 1, the equivalent binary of that is present at the input. That is what it indicates. That means if I am having a box which is acting as a 2:4 decoder, what does it mean? The output lines are 4. Okay, so if 1 is present at the second, the second output, what does it indicate? The equivalent binary. What is that? Of the position, what is that? 0 1. 0 1 is present at the input. That is what it indicates. That's it. So encoders and decoders may have multiple inputs, multiple outputs. No selection lines here. ये बताया नहीं, मतलब कुछ है नहीं इसमें, ठीक है. So these are used, but we have seen BCD to gray code, decoders. We have seen multiple access3 देखा हुआ है हमने, ठीक है. What if you need to design this using Verilog? Now we may use, okay, so there are multiple ways to do this. I am asking you to write a Verilog code, okay, using gate level representation. Okay, using gate level representation. That means what? How can you design this? First you tell me the circuit. How it would be? For 0 0 only the first bit is 1. How can I do that? ओके इसकी अगर के मैप निकालते बैठोगे ना हर एक इसमें एक ही 1 मिलेगा. ठीक है उसके हिसाब से चलते हैं. Now why do you need K map? I mean you must have that that level of understanding to get directly the expression. Only one is there in the only one entity, right? So it is what? I mean this is 1 only if A bar and B bar is there. That means Y0 is A bar B bar simply. So you may form circuit directly. What about this? A bar B. This is A B bar. This is A B simply. So I can simply write this circuit. That means see A का complement भी available है and uncomplemented भी available है. B का complement and uncomplemented भी available है. How can I define? Okay, sorry. See here. So if this is the input, I'm expecting its complement to be available. ये बताया था मैंने डायरेक्टली. अगर नहीं बताया तो समझना चाहिए आपको. ठीक है अगर मैंने पढ़ाया भी नहीं होता इफ आई एम एक्सपेक्टिंग कि मतलब ऐसा आउटपुट होना चाहिए यू शुड बी एबल टू ड्रॉ इट. ओके ये पिद्दी सी बातें आपको आनी चाहिए. आई एम सेइंग दैट एक्स एंड विच आर द इनपुट्स. आई कैन डिफाइन एनीथिंग ए एंड बी. ओके ठीक है ए एंड बी. ए बी ए का बार चाहिए ना अपने को. ए एंड बी बार आर प्रेजेंट. ठीक है ये क्या हुआ ए बार बी बार. आउटपुट बोलो क्या है. एंड गेट्स लगेंगे. कितने एंड गेट्स लगेंगे बोलो. 4 एंड गेट्स निकालो. क्या क्या कनेक्ट करूं बोलो. y0 के लिए बोलो ए बार बी बार यहां से लूंगा बी बार. पहले देख लो ए बार एंड बी बार. ओके ए बार एंड बी बार. आई एम शोइंग द कनेक्शंस लाइक दिस. ये यहाँ पे कनेक्टेड है इधर कनेक्टेड नहीं है एंड सो ऑन. करो बनाओ सर्किट. क्विक. बिना बोर्ड पे देखे बनाओ. ड्रॉ द सर्किट. और इसका कोडिंग करेंगे वेरिलॉग में. ठीक है गेट लेवल डिजाइन कैसा करोगे बोलो. इनपुट कौन से डिफाइन करोगे. ए एंड बी इनपुट. आउटपुट बोलो. अब देखो इंस्टेड ऑफ डिफाइनिंग y0 y1 y2 y3 ओके डिफाइन एज एन एरर. इनपुट को भी एरर डिफाइन कर सकते हैं क्या. इनपुट को भी डिफाइन कर सकते हैं एरर. देखो यहाँ पे सी मैं क्या कर रहा हूँ कि ये जो इनपुट है नाउ इट डिपेंड्स व्हाट इज ए एंड बी. ए आई एम कंसीडरिंग एज MSB राइट. सो इट इज x ऑफ 1. ये x ऑफ 1 का बार. ओके इट्स इनवर्ट ऑपरेशन हियर. I'll write it bar here. This is x of बोलो x of 1 का बार, दिस इज x of बोलो 0 x of 0 का बार. मतलब हम ऐसे ड्रॉ कर रहे हैं सर्किट. We are drawing the circuit like this. Two input, four outputs. So I am defining this complete input as x and the complete output as y. So this is y, this is x. Alright? हाँ, करो कोडिंग. कौन कौन से गेट्स लगेंगे बोलो.
गेट्स, एंड गेट और नॉट गेट, दैट्स इट. मुझे सिर्फ आपके कोडिंग में सिर्फ दो ही गेट डिफाइन हुए लिखने चाहिए. ओनली टू कीवर्ड्स, एंड नॉट, दैट्स इट. डू दैट. स्टार्ट योर प्रोग्राम. मॉड्यूल लिखो.
इथे बसू शकतो.
राइट यूजिंग वेक्टर. वेक्टर डिफाइन करो, आएगा आउटपुट आएगा. very good. That's written it. Okay. Once you try with big vectorization and without vectorization. Okay. Yeah. कीवर्ड यूज कर सकते हो क्या? कैन वी यूज कीवर्ड विद इन कीवर्ड? ट्राई करके देखो. ट्राई करके कीवर्ड इज लाइक अ वेरी बेसिक थिंग. ओके, उसके अंदर और बेसिक नहीं हो सकता. You may consider the this one x0 and x1 as the input. Okay, only one variable, and this you may consider as bias or in your output. Bias you can consider as this. ये wire ही है ना, तो NOT gate के output को wire define कर लो. What I am saying is, instead of defining this like this, ये देखो यहाँ पे वायर का MSB, वायर का LSB. Now the thing should be clear. 0001. So it should be one zero one one. This is how the circuit would look like. So this is Y0, Y1, Y2, Y3. So you may define inputs as uh, 1:0 X. You may define output as vector again. बोलो 3 to 0, 3 to 0 Y, and wires 1 to 0 as W. Now the thing should be clear. How to address this? Addressing कैसे करोगे इसका? बोलो. ब्रैकेट से करोगे, ठीक है? देखो यहाँ पे ध्यान दो. Suppose I want LSB of Y. How to define that? I mean, how to use that? Y of 0. That means like this. Okay, using brackets. What if there are I need to use two contiguous bits? यहाँ पे ध्यान दो. What if I need to use two contiguous bits in Y? Let's say first bit and second bit. How can I do that? Y 1 2 1 to 2, no? 2 to 1. That's it. So I'll be addressing only the second and the third bit. Okay. So I mean Y is like this now. 0 0 1 0. Let's take any Y. So Y3, Y2, Y1, Y0. So this indicates I am addressing this. Write the code. New code.
I'm using vectorization here. So module name, let it be decoder 2:4. The variables are x, y, input is 1:0 x, output बोलो 3:0 wire. See, wires are nothing but the intermediate values, okay, temporary variables you can say, but those are not the terminals taken out. Wires are for internal connections, these are called as nets. Again I am saying wires बोलो 1 to 0 के बाद बोलो यहाँ पे क्या लिखूँ, नॉट. फर्स्ट डिफाइनिंग द नॉट गेट. क्या आएगा यहाँ पे, अब x का 1 y w का 1 रहेगा, ठीक है, नॉट गेट है ना. सो w का 1 में जो आउटपुट आएगा वो x का 1 का रहेगा, नॉट गेट. ये सही है. MSB of x and negation of that will be saved in w of 1. Copy that. So I don't need to use again and again not gate. So w of 0 x of 0, ये सही है. MSB to MSB, LSB to LSB. उसके बाद and बोलो. Yes, well y0, alright. इनपुट्स क्या करेंगे, 0 0 ना, मतलब इन्वर्टेड. x और x0 और x1 का इन्वर्टेड क्या है, w0 और w1. लिखो वहां पे w1 और w0. उसके बाद I will simply copy this. y1 बोलो यहाँ पे क्या आएगा, 0 0 0 1. बोलो क्या लिखूं, एनीवन. यहाँ पे क्या आना चाहिए इनपुट्स में, हाँ y1 इज 0 0 हो गया ना. 0 1 चाहिए अपने को. 0 मतलब ये इन्वर्टेड है, इन्वर्टेड MSB. इन्वर्टेड MSB क्या है, हाँ w1 कॉमा बोलो हाँ x0. ये यहाँ पे कंफ्यूजन नहीं होना चाहिए. उसके बाद यहाँ पे बोलो 0 0 0 1 हो गया, मतलब ये 0 1 जो है इंडेक्सिंग सेम रहेगी, ठीक है, बस यहाँ पे चेंज होगा. 0 0 0 1 1 0 ना, यहाँ पे x, यहाँ पे w, ठीक है. यहाँ पे क्या रहेगा, y2. आखिरी वाला बोलो, आखिरी वाला x w, सॉरी x0 ना. इज दैट ओके? किन लोगों को ये नहीं समझा है? How many of you didn't get this? How many of you didn't get this? सबको समझा है, वेरी गुड. एग्जाम में देखेंगे. एंड मॉड्यूल, दैट्स इट. राइट द टेस्ट बेंच. This looks more compact, otherwise you will be using 4 different variables, wastage. You know, it's like more compact and nice clean form of Verilog coding. See, marks are there for cleanliness, optimization and correctness. मतलब आप बहुत अच्छे से लिख रहे हो, ऑप्टिमाइज भी कर रहे हो, आउटपुट नहीं आ रहा है तो 0. आपका आउटपुट आ रहा है पर बहुत लंबा है, ऑप्टिमाइज नहीं है, 0. Okay, I will specify in what sense I am expecting the output. टेस्ट बेंच बोलो फटाफट. मॉड्यूल _tv. और जो लोग सेपरेट वेरिएबल यूज कर रहे हैं उनका आउटपुट कुछ अलग, मतलब वो दे विल हैव टू स्ट्रगल टू not struggle, but I will say they will have to keep trace of where the bits are getting 0 and 1 individually, and those who are doing vectorization form, they will get the its binary representation directly. We'll come to know. Okay, go with both the ways. Okay, you may try going for vectorization form first and then the separable form, or you may define the outputs as individual variables first and then the vectorization later. Reg. Now everything I'll copy this. Instead of this I'll write reg. That's it. Well, after this initial begin. So what should be the addressing? Like what I'm varying, only x I'm varying, right? So x of, now MSB to LSB, no? That is how we define x of 1 0 and x of 0 0 and so on. Copy this hash 10 0 Alright, see if you are getting the output. Dump file. See, this dump file is required in such simulators. .vcd dump vars. And what is missing? The instance. I'm planning to make the end semester as open internet. Okay, so be ready for any challenge. Open internet, open books. Okay, I'll try to do that if I get the permission. Okay. Instance name, run this. In design, tell me. Can you speak loudly, please? उसके बाद ओके, या थैंक्स फॉर द करेक्शन. W नहीं, मैं अपना नाम भी लिख सकता हूँ, मतलब कुछ होना चाहिए. What if I don't give? I don't want. Let's see what it does. It will ask me to do that. Let's see. Let's run this. So we pop an error saying that that W is not defined. Syntax error, invalid module item. Okay, line 5. So that is what the error will get. If you don't define the W, I'll get some error like invalid module item. Okay, I'll define that. Alright. Syntax error at 6 in test bench. Let me see. Okay, again the W is not defined here. Okay, I won't show the output, but okay, you define your own program. Okay, write your own program. See what the output you get. How many of you are going with individual variables? Individual variables. Why को individual variables आप करो? दोनों टाइप से करो individual variables और vector.
SQL.
आउटपुट क्या है?
इंटरप्रेटेड। जो लोग वेक्टराइजेशन कर रहे हैं देखो यहाँ पे, देखो यहाँ पे ध्यान दो, आपको कुछ ऐसा आउटपुट आ रहा होगा। दिस इज वेक्टर 2 bit, it's an equivalent binary representation of that 2 bit, so it is 0, that means it is 0 0. For 0 0 first line should be 1, 0 2 3, right? First line is 1, I mean first line is 1 means what is first line? 1 equivalent binary 0 0 0 1 na? What is its equivalent decimal? 0 1. दूसरा line should be 1, rest of them should be 0. What is the binary equivalent of that? 0 0 1 0, yeah, that's 2 4. How many of you didn't get? सबको आ गया? ठीक है, very good. Let's go ahead. All right, observe, like, see, so far we have used the gate primitives. See, we have seen a lot of things today. We have seen how to use this. Okay, let me put down the things. We have seen first how to define the primitives, user defined primitives. We have seen in tabulation or lookup table form how can we define its function. We have also seen the vectorization form. Okay, Now let's see, so far we have used the gates. Okay, the modeling is called as a gate level modeling. Okay, that's not the only way in which Verilog coding is available. We can code using what is called as a, now let's see, so far we have seen gate level. Let's look at what is called as a data flow modeling. Now in this, okay, the AND primitive is equivalent to this symbol. Okay, so this symbol, okay, let it be, or is equivalent to look, one, yeah, hi Manish, tell me. Yeah, it's still in process, I guess. I'll just confirm it and let you know. Who? Acha, Rajan sir. Okay. He's yet to come, I guess. I'll just make look after that if it is available or not. I'll let you know. Okay. I'll call you. I'll call you back. Yeah. Okay, so what I'm saying is AND is equivalent to this, OR is equivalent to this, NOT is equivalent to this, an exclamation mark. And okay, so as to use this, always you have to make use of assign command. Assign, the syntax is assign, the output variable y followed by the syntax, okay, equals to, and whatever the expression you want. If it is a and b, it should be like a double and b. Now please note that ये double दो बार जो है इसका अलग मीनिंग और एक बार लिखने से अलग मीनिंग है. Okay, now you should see, this is what is called as a logical AND, logical OR, and a logical NOT. If I am writing this ampersand sign only once, that indicates bitwise AND. Okay, if the variables are vector, it will act bitwise. But see, you should be very careful while using this operators. Okay, if the operators are scalar or bitwise, or sorry, the logical variables are there, scalars, use these operators, double wala. Okay, if it's a vector, if you want bitwise operations to be happening, okay, you use this only once. Okay, there is a difference. Okay, for example, a and b, you should specify it like this. Now I am giving you a task, like you design the 2:4 decoder which you have done so far using gate level. You define the same thing using data flow mode. Okay, do that. You will find that it's much easier, and this is what is widely used. Okay, data flow modeling is what is people may go for mixed approaches also. Okay, mixed modeling also. So this is what is called as a data flow modeling. Okay, where you use continuous assignment statements. Okay, whenever you find this assign statement, that is a data flow modeling. Whenever you find the gates primitives to be there, you name it as a gate level or a structural modeling. Do that. Syntax कहाँ पे बदलना पड़ेगा? सिर्फ main module में बदलना पड़ेगा. Okay. You can make use of parenthesis if you want. इसको लिखोगे कैसे? A बार B बार कैसे लिखोगे? Y0 assign Y0 equals to, now A का बार है ना, उसके ऊपर ये ऐसे bar of A. Okay. Okay, always have a practice to give parenthesis. Okay, if you don't give, it may interpret it differently. I mean, these brackets are given first preference. Okay, similar to the C coding. And bolo V bar. So there is an exclamation mark and B. Terminate with a semicolon. ऐसा लिखो y0, y1, y2, y3 लिखो फटाफट. रन करो कोड, देखो रन हो रहा है क्या.
So each bit it will invert, or each bit it will add, and so on. He will not fail you. Yeah. Semicolon बहुत important है. हाँ, वायर की जरूरत नहीं है यहाँ पे. वायर लगा दो. Assign the keyword, you must write assign. देखो आप जब भी ये कोडिंग कर रहे हो, ओके, यू सेव दिस कोड बिकॉज इट विल बी वेरी यूजफुल टू यू.
अब जब भी कोडिंग कर रहे हो ये सेव करते जाओ, आपके अकाउंट में सेव होंगे ये. एंड यू विल गेट यहाँ पे सेव करने के बाद यहाँ पे जो URL मिलेगा, यूजिंग दैट यू कैन शेयर. ये 6EDU ये अगर आप डालोगे तो ये मेरा कोड दिखेगा. Now it is public, anyone can view. You can try entering this 6 capital EDU, you will see my code. Okay, it's very useful. Okay, save करते जाओ, आपकी खुद की कोडिंग है. असाइन स्टेटमेंट यूज करो. असाइन स्टेटमेंट के में फिर वायर्स नहीं लगेंगे, वायर्स हटा दो. वेक्टराइजेशन यूज करो, वेक्टराइजेशन विदाउट वेक्टराइजेशन यूज करो. आउटपुट आ रहा है सबका. असाइन का कितने लोगों का आउटपुट आ गया है? असाइन का करो फटाफट.
You may have to look at those expressions, okay? Those are like no clean and no compact. आगे सबका
वायर्स हटा देंगे. So I'm simply writing assign. So I'm using both vectorization and assign statement. So this becomes which modeling? Data flow modeling. Y of 0 as x of 1 and x of 0. Oh well, you don't need to use this assign statement again and again. Okay, same thing applies here. Okay, avoid redundancy. मैं ये बोल सकता हूँ कि आपको सिर्फ 50 लेटर्स अवेलेबल है, उसमें आपको वेरिलॉग कोडिंग करना है, तो कैसे करोगे? 51 लेटर आ गया, 0 मार्क्स, स्पेस भी नहीं चलेगा उसमें, फिर कैसे करोगे? See, the spacing here is only for readability. It's not required anywhere. I mean, except at some places. Y0, Y1, Y2, Y3. Should get the output. Let's see. I think it's working fine for me. Hey? Something wrong here. Oh, I've simply repeated. Not like this. And 0 0 na first. So ampersand. Sorry. This one. This should always be 1 1 1, and this should always be 0 0 0. Zero 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 1 1 0 and 1 1. Okay, now it should run. Great. So I think it's working fine for me. It should work for you as well. किन लोगों का आउटपुट नहीं आया है? असाइन का आउटपुट किन लोगों को नहीं आया है? नहीं आया है? 1 2 और सबका आ गया? 1 2 3. वेरी गुड. काउंटर्स हो गया क्या आपको? काउंटर्स हो गया हार्डवेयर पे? हार्डवेयर पे नहीं होगा, आज काउंटर्स करेंगे. मतलब अगर ये हो तो फिर सभी के सभी एक्सपीरियंस आपको वेरिलॉग में करना है. ठीक है. Okay, let's stop here.